Today, our objective is to review scientific notation. I would imagine one time or another in a math class, probably you dealt with scientific notation. What do you think? Would that be a correct statement? Okay. So we're just going to review a little bit of scientific notation. Well, what is it? It is a way of expressing really, really big numbers or really, really small numbers. Really big numbers, really small numbers. For very large and very small numbers, it is more concise to write scientific notation. Now let me show you a number. That number right there, would you say that it's a pretty big number? Yeah, that's a pretty big number. That guy right there is what we call Avogadro's number. We tend to write Avogadro's number in scientific notation, okay, because we like to shorten it up. So, I would write Avogadro's number as so, 6.02 times 10 to the 23rd. That's a little bit shorter than having all those zeros. Yeah. Avogadro, don't worry about it now. We'll get that next week, okay? Don't worry about Avogadro's number yet. We'll hit that when we talk later on. Now, a little bit easier to write scientific notation for that number, right? And you don't have to write that number down. I'm just using it as an example because I see people out there going, how many zeros is that? I'm losing count. Okay? It's a lot. It's a lot. So don't worry about that. I was just showing you an example, this Avogadro's number. So the whole reason we use scientific notation, very, very big numbers, really, really, really small numbers, it's a way to shorten them up. Okay, a way to shorten them up. It consists of two parts. A number between 1 and 10. And a power of 10. So this n right here is a number that is between 1 and less than 10. So we should never have 10 as n. It should be somewhere between 1 and 9. Okay? So 1 or greater and less than 10 is our scientific notation. Well, how do we do it? How do we do it? Like this. And I'll give you a second to copy that down. Place the decimal point so that there is one non-zero digit to the left of the decimal point. So we're going to start off on our numbers to make sure that there is one non-zero digit left of the decimal. Count the number of places the decimal point has moved from where it was originally at. That will be the exponent of the 10. Finally, if the original number was less than 1, the exponent is negative. If the original number was greater than 1, the exponent is positive. Simple enough. Here's the examples. We're going to look at this. Now, first of all, as we start this off, there is not a decimal in this number, 289,800,000. There's no decimal. So where does the decimal go? Where does it belong? Jacob? Behind the last zero, right here, correct? Now, our rule told us that we need to make it so there is one non-zero left of the decimal. So I'm going to put my decimal right here. So now I have changed it to 2.898. Why did I not include all those other zeros? You're going to see why later on when we talk about significant digits. All right? That's why, because those are not significant. Now I need to determine how many places that I jumped that. So I just look at it and I go like this. I count 1, 2, 3, 4, 5, 6, 7, and 8. So I moved it 8 places. Therefore, my exponent is 10 to the 8th. Why positive 8? Because that number is greater than 1. Now, on the bottom one, I see that this number is less than 1, so I'm going to have a negative exponent. I am going to move my decimal to right here because I want one non-zero digit left of the decimal. Moved it there so that I jumped it 1, 2, 3, 4 places. So that gives me 5.67 times 10 to the negative 4th. Now, this is working in the other direction. To change scientific notation into standard form. We simply move the decimal point to the right for a positive exponent. We move the decimal point to the left for a negative exponent. And then we use 0 to fill in the places. So, if I have the number 5.093, I take the 5.093 times 10 to the 6. It's a positive exponent, so I'm going to jump that 6 places to the right. 1, 2, 3, 4, 5, 6. I need to fill in 3 zeros. So when I clean up my number, it's going to be 5,093,000. 5,093,000. Now, as I look at a negative exponent, I have 1.976, and I can see I have a negative 4. So that tells me I'm going to jump it 4 spots to the left, because it's negative. 1, 2, 3, 4, and I'm going to fill in zeros. So my new number is going to be 0.0001976 because I moved my decimal 4 places to the left. Now, what I want you to do is I'm going to give you a little time. Write in your notebook. Write in your notebook number 1 to 5 and answer those. All right. Here we go with our learning check. What I'm going to do is my decimal's here. I'm going to move it to here. So my number is going to be 4.05789, and I've moved that 1, 2, 3, 4, 5 times 10 to the 5th. My second one, move my decimal to there, jumped it 1, 2, 3, so it's going to be 3.872 times 10 to the negative third, because that number was less than 1, so it's a negative. This one, well, there's a lot of zeros there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 times 10 to the 9th. Now, this one might be the hardest one. This one might be the hardest one because do I have to move my decimal? It's already there, right? So how many did I jump it? None. 2 times 10 to the 0. Finally, the last one. It's going to give me 4.78260 times 10 to the negative 1. I jumped it 1 spot to the right. It was less than 1, so it's a negative value. Okay? That's all scientific notation is, folks. Now, you're going to be doing WebAssign. You're going to be doing WebAssign. So, how would I write these on WebAssign? Most of the time, they'll show you how to write it. Okay? But if I were going to write, let's say this number right here on WebAssign, I would put 2. Excuse me, that's a 3, isn't it? My bad. Okay? I'll do it in a different color. 3.872 e to the negative 3. That's how I would write that number on WebAssign. This one, 3e, I could put plus 9, but I don't have to. I could write it like that, or I could write it 3e to the 9. WebAssign will read it both ways. So when you're writing WebAssign, that e means the times 10. Now, a lot of the times you're going to see throughout the year if I'm doing checks, okay? If I'm doing checks to see, okay, do we understand what's going on? I'll do thumbs up, thumbs down, thumbs up, thumbs down, thumbs maybe, okay? So I'll ask, just simply like this. We got thumbs up? Are we okay? Are we okay with scientific notation? Okay. All right. So that is all I have for you today.